Anna borrows 15,000 from our local credit union to buy a new car. The annual percentage rate APR is charged at 6.99%, fixed for the term of the loan. She agrees to repay the loan in equal monthly repayments over 5 years. So that's 12 payments a year, that's 60 payments, okay? When the first repayment due 1 month after the loan is issued, so she's paying at the end of each month. Show that the rate of interest compounded monthly, which is equivalent to APR of 6.999, is this. Alright? So, what do we usually do there, right? So, we do 1.0699 is how you increase the value of something by 6.99%, and that will equal, for argument's sake, a number to the power of 12, okay, or 1 plus the monthly interest to the power of 12. Is that okay? And I'll just call 1 plus r, I'll just call that my x value, okay, x power 12. Now what I'm going to do to get x on its own is I'm going to 12 root this. 12 root 1.0699, and when I 12 root that, shift 12 root 1.0699, I got 1.0564, which equals 1.00555646. Okay, now these are 10%, that's a%, and this is 0.5%. So when I say x equals, what did we say earlier, 1 plus r equals 1.005646, r on its own in decimal is 0.05646. And if you multiply that by 100, you'll get it in its percentage, which is r equals 0.45646%. And that is question 5a done. Okay, after repaying the loan for 3 years, Anna decides she wants to change her car. By finding the present values of her remaining payments, calculate how much Anna still owes the credit union at this time. Okay. So, she has 2 years of payments left. So 2 years by 12 is 24 payments. She has 24 payments left. Okay. So, she decides she wants to change her car by finding the present value of her remaining repayments. So all these payments are made in the future, right? So, in 1 month's time, there will be a repayment. Okay, now does it give the repayments? Alright. Sorry lads, there's a 5a part 2. Here we go. Before I do 5b, there's a 5a part 2. Find the amount of each monthly repayment correct to the nearest payment, right? So that's no bother. 5a part 2. Alright, so we're going to use the, it's essentially like paying a mortgage. It's very similar, it's basically mortgage payments. You're paying these in the future. So it's your principal, 1 plus I to the power of t, and then all over 1 plus I, 1 plus I to the power of t, take away 1. Now the reason why it's like a mortgage repayment is, in a mortgage, let's say you're paying €1,500 mortgage at the end of each month. These are all payments you make in the future, and they're worth less today. Okay, so all these payments are worth less today. Okay, so example being, if you were paying €800 on your mortgage per month, and the longer in the future you make this payment, the less it's worth today. Alright, and we're going to find out what is our current value of how much so that's why we can use the mortgage formula. Okay, we use the mortgage formula basically because it's future payments value today. Now, the present day, the value of this at the moment is 15,000, I believe, according to the question. 15,000. Okay. Now remember, we're doing monthly repayments, alright? So we do this using the X value on our calculator. So X equals and there's also an I in here. It's PI 1 plus I to the power T for the mortgage repayment, right? So X equals I, and actually what letters am I going to use? Actually I'll use A and B. A equals I, B equals 1 plus I. Okay, and our I value is 0.0, it has to be the decimal one, 0.005646. Okay, so 0.005646. Okay, store it as A. Okay, and then 1 plus I, or technically 1 plus A is B. So B is 1 plus A. So once again, click A. 1 plus A. Yeah, that's the number we want. And then we're just going to go Shift. Press star. Star is B. Okay, done. So the way my one works is like this: 1,500 A by B. Now T is how many payments we're making, and if I remember correctly, we're doing this for 5 years, which would be 60 repayments. So B to the power 60 all over B to the power 60, take away 1, and it's a lot easier to put this into the calculator. 100, 500, 15,000 A, and then B to the power 60. And then it's B to the power 60. And then you take away 1. And you get €295.43. So 295.43. Sorry, that's A part 2 done. Now, after repaying the loan for 3 years, Anna decides she wants to change her car. By finding the present values of her remaining repayments, calculate how much Anna still owes the credit union at this time. Okay, so how much does Anna owe the credit union at this time? So, alright, so think of it like this. We're getting the present day values. So no matter what happens, we're locked in for paying €295.43. In 1 month's time, I'm going to have to pay that. In 2 months' time, I'm going to have to do another €295.43. So I'm 3 years into my loan. I'm at the start of year 3, and so I'm starting year 3. And what happens is, in 1 month's time, I'm going to have to pay all this, and then I'm going to have to do that for 24 more payments. We're going to have to do all of this. Okay. Now what I'm going to have to do is I'm going to have to calculate the present value of these. So these future repayments cost less today. All right. So this €295.43, that's in 1 month's time. I can say that's divided by 1.00. I'll take away the month's interest. All right, and that's the power of 1. And then the next one is 295. The one that I pay in 2 months' time will be divided by this number squared, and then the one that's at the end of 24 months will be 295.43 divided by 4 months' time. Or sorry, 24 months' time. Oh sorry, the bottom's to the power 24. €295 divided by 24, power 24 months. Now this is a series, okay? And if you take this series as, that's T1, that's T2, okay? And this is a T24, okay? So your A value is T1, and T1 is €295.43 all over 1.00546. And at the end of each month, you just add on another power on the bottom. You keep adding on, you keep multiplying it. It's a geometric sequence, and you keep multiplying it by this number here. An extra power keeps appearing on the denominator. That's what keeps happening over and over again, okay? So that means that the R value is 1 divided by 1.00546. Okay? Now if we use an Sn for a geometric sequence, it's 1 minus r to the power of n all over 1 minus r. Okay? And the Sn is going to be, so we're doing S24 because there's 24 separate payments. And it's going to be our A value, which is 295.43 all over 1.00546 into 1 minus r, 1 over 1.00546 to the power of 24, all divided by 1 minus the r value, which is 1 over 1.00546. Now, I think what we're looking at here, lads, is actually some of the hardest parts here is actually putting the thing into the calculator. It's quite difficult. Start off with a fraction button, and then start off with the 295.43 divided by 1.00546. Okay, then open up a bracket, 1 minus, and then open up another bracket with a fraction, 1 on top, your 1.00546. Now, 1 second, did I drop a decimal? Ugh. Actually, lads, just shows you, it's 5646. So all of this has to be 5646. 5646, 5646, 5646, 5646, 5646. So it's very easy to make mistakes with these numbers. You need to be double checking. You need to be double checking that you put in the right number. Don't get it mixed up in your head. Okay. Put all that in the calculator. So, fortunately for me, 5646. It's a quick fix anyway. 5646, and now I'm at the bottom, and I'm going to do 1 take away 1 divided by 1.0054646, and I'm hoping that this comes out to be 6,613. Now I've made a syntax error somewhere, so let's find out what happened. Okay, oh, I never finished off the top. I have to do it to the power of 24, and I have to close the bracket. 6,613.50. So actually, when I was doing this question, I actually forgot to do this part here. So just be very careful of when you're doing these. They can be quite tricky. Right, now we're on to question 6, thank God. Now, I'm going to find the range of values for what this happens. So I'm going to move this all over one side. So I'm going to get 2x plus 1 less than or equal to x plus 3. I'm going to square both sides. Okay, so we're going to get 2x plus 1 by 2x plus 1 less than or equal to x plus 3 by x plus 3. That's what you generally do when you get the modulus sign, just square both sides. We're going to get 4x squared plus 4x plus 1 less than x squared plus 6x plus 9, transferred all over one side, and we get 3x squared minus 2x, what's that, minus 8. Okay, now this is a U-shaped function, and this U-shaped function will cross the axis usually twice. Okay, and we got to figure out what 2 points does it cross the axis at. Now you can do the minus b formula if you want. For me, I'm probably just going to break it up like this. I'm going to solve it equal to 0 to find out the 2 points where it intercepts. I think it's going to be 4 and 2. Probably 4 and 2. Yeah, that's going to be 2, and that's going to be 4. I want it to be minus, so that'd be minus 2 and a plus 4. Yep, and we have our two answers here. We're going to get 3x plus 4 equals 0, 3x equals minus 4, x equals minus 4 over 3, and then x equals 2. So here's my 2 points. That'll be 2, and this can be minus 4 over 3. And we want it to be less than 0. So we want it to be below the x-axis, not above the x-axis. So we want the green region. And the green region is any x values in between minus 4 over 3 and 2. So that's minus 4 over 3 less than x less than 2. Right, that's worth 10 marks. Now, the next question is, we're given this function here, right? And what happens is they don't actually graph that function. What they do is they actually graph the derivative, which is the slope function, okay? So what I'm going to do straight away is I'm just going to differentiate this. And when I differentiate it, I'm going to get 3ax squared, 2 times b, I'm going to get 2bx, and then I'm going to get plus c, and then d is a normal number, I'm going to drop the d. Okay, and that is a good few numbers. That's a good way of starting it off. Okay, now the great thing about this function is I actually have values for it. So I have the point minus 2, 0. So an x value of minus 2 in this function will give me a y value of 0. Alright, so that's a good starting off point. Okay, and then it's going to be 2b times minus 2 plus c. Okay, now what other point do I definitely know? I also have the point 0, 4, which is very handy as well. So anytime I put in an x, 4 will be the y value. Anytime I put in an x value of 0. 3a times 0 squared, no bother. 2b times 0. And then we have, what's that, plus c. And then what we learn here is that the c value is 4. Okay? Now that we learned the c value is 4, because all of this will be 0, 4 will equal 0 plus 0 plus c. C value is 4. Happy days. Now what I'm going to do is I'm going to put in a c value of 4 here. Okay, going to multiply this out. 3a, that's going to be 12a. That's going to be minus 4b. And that's going to be 4. And then if I move the 4 over the other side, I'll basically get 12a minus 4b equals minus 4. You can basically say that's minus 4 when you move it over the other side. And then that's 1/2 of a simultaneous equation, alright? So that's a good half of a simultaneous equation. I'm pretty happy about that. Okay, I'm going to bring it over. Now, do I know any other points that I could use? Well, I know that when the x value is 2 over 3, when the x value is 2 over 3, the y value is 0. It gives me that point. So I'm going to use it. Okay, so it's going to be 3 times a times 2 over 3. squared plus 2b times 2 over 3, that's plus or 4, and the y value would be 0. Okay, and then what I should get here is, that's going to be 4 over 9, so it's going to be 3a by 4 over 9. And then it's going to be 2b, so it's going to be 4b over 3 plus 4. The 3's will cancel there, won't they? So the 3 and the 9 will cancel, so that'd be 4a over 3 plus 4b over 3 plus 4. Now I'm going to turn that into thirds as well, so that'd be 12 over 3. Get rid of the 3's then, because 3 on both sides doesn't matter. The 3's just cancel. And then I'm going to get 4a plus 4b equals minus 12. Now I have my 4a plus my 4b equal to minus 12. Then I'm going to have my 16a equal to minus 16. I'm going to get my a value equal to minus 1. So there's my a value. Now if that's minus 4 and that's 4b and that's minus 12, 4b equals minus 12 plus 4, 4b equals minus 8, and b equals minus 2. So I have an a b and a c value. I'm hoping. Yep. Now, finally the d value, okay? We're told this, that when you use the original function, and the original function is ax cubed plus bx squared plus cx plus d, and under r that's minus x cubed minus 2x squared plus 4x plus d is f of x, and what we're told is that when we have an x value of 2, the y value is 0 for the original function. So that means 0 equals minus 1 to the power 3 plus 2 times 2 squared plus 4 times 2 plus d. Now I think that means that the 2d's are actually 8, so they cancel. And then I think that's minus 8 plus d equals 0, and d therefore equals 8. Now I have my a, b and c and d values. I have them all, alright? Now, next one. Hence solve this equation equal to 0 and sketch the graph of f of x on the diagram on the previous points. Alright, no bother. So f of x is currently minus 1x cubed plus what else do we know? 1x cubed. We know, what's it, bx squared minus 2x squared plus cx. And what did we say d was? D is plus 8 or minus 8? D is plus 8. Okay. Now, if we didn't know how to do this already, you can throw it all into the calculator and sketch the graph. No bothers, alright? So we go here, and we actually already know one of the roots. We already know what value makes it have a y value of 0. Okay, I'll explain how in a second. Okay, start out, I don't know, minus 10 to plus 10, and we'll see what happens. Alright, now here we go. Minus 2. When x equals minus 2, the y value equals 0. X equals minus 2 is a root. We also know 2, 0. When x equals 2, y equals 0, x equals 2 is a root. And then finally we don't know the third one. Now we already knew this because it told us that f2, when x equals 2, the y value is 0. And that already told us this information here. So we're going to use the factor theorem. If x minus 2 is a if x equals 2 is a root, x equals minus 2, x minus 2 is a factor. Now we're going to long divide this in. X minus 2 all into this equation here. It should be handy enough to pull off. Goes in minus 1x squared times. So minus 1x squared is multiplied out and we get minus 1x cubed plus 2x squared minus, and what's it, minus and minus of minus, so that'll be minus 4x squared, and then we have plus 4x. We divide it again, minus 4x squared by x, and we get minus 4x. Multiplied out again, we get minus 4x squared. Minus 4x squared plus 8x. Now take them and change the signs, and now we get minus 4x plus 8. And then what we get here is it's going to be minus 4. Then when you multiply that out, it's going to be minus 4 by x, minus 4x plus 8. So minus 4x plus 8. Then you take them out, change the signs, and it turns to 0. Now, what we're making the claim is that, see the way it wants f of x equals 0? This part here, this is f of x. And what it's saying is, I want this to be 0. Okay? And we're saying, no bother. Because we're saying that this is actually the exact same as x minus 2, and then minus 1 x squared minus 4x minus 4. Okay? Now, what I'm going to do is I'm going to factorize out the minus 1. See the way they're all negative? So I'm going to have it as minus 1 multiplied by x minus 2, and then this part is going to be x squared plus 4x plus 4. Okay? Now, when we factorize this, it's going to be x minus 1, x minus 2, and this is actually going to be x plus 2 twice, which means that it's a repeated root, which means it touches the axis and goes back up again. Okay, and this is going to be x equals 2. So you're solving these roots here. That's x minus 2 equals 0. That results in x equals 2. And then that's x plus 2 equals 0, results in x equals minus 2. So when you draw your graph, here's what's going to happen. Well, we already know how to draw it roughly. Alright, so 0, 0, 8, is it? Here we go. Right, so 0, 8. Minus 1, 9. 2, 0. What is it? 1, 9. Sorry, it's 1, 9, not minus 1, 9. It's minus 1, 3. Minus 1, 3. It's minus 2, 0. 3 minus 24, minus 25. So it's really gone steep there. So it's very steep to here. Now, could do my trick of getting some 0.5s in here, just to make the graph a bit easier on myself. So I'll go again. I'll start at minus 3. I'll end at 4, and I'll dot in some 0.5s just to make my life easy. Minus 3 plus 5. Oh, that's interesting. minus 3 is plus 5. Minus 2 is 0. 1.5 is 0.8. So it's really concaving in. And then 2.5 is 1.125. Alright, so by drawing these green dots, I've actually learned how to draw this properly now. And then what's minus a half is 5.6 there. Okay, and then plus a half is 9.3. Plus a half is 9.3. And that comes down again. And then 1.5 is 6.21. Yeah, to be honest, lads, I need those extra points to make this work. And then 2.5 is minus 10, so that's like sharp. That's it there. That's your U-shaped graph. Whoa, 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 whoa. Nope. I made him. Oh, sorry. Yes, that's the repeated route. That's the one where it hits the axis and bounces back up again, and that's the one where it goes straight through. Exactly. Thank God for the table function. Alright guys, I think that's us done there, so that's questions 5 and 6.